Well, good afternoon and welcome to the Iowa Learning Farms virtual field day this afternoon. It's a pleasure to have you all joining us. I'm Liz Ripley, the Conservation and Cover Crop Outreach Specialist with the Iowa Learning Farms. And for those of you that may be new to joining us, a little bit about the Iowa Learning Farms. We are based on campus at Iowa State University, and we were established in 2004 with the goal of building a culture of conservation. And all of that is made possible through partnerships. So that includes the Iowa Department of Ag and Land Stewardship, USDA Natural Resources Conservation Service, USDA Natural Resources Conservation Service, as I mentioned, Iowa State University Extension and Outreach, the Leopold Center for Sustainable Agriculture, Iowa Department of Natural Resources, US EPA Section 319, Conservation Districts of Iowa, Iowa Farm Bureau, Practical Farmers of Iowa, GrowMark, Iowa Agriculture Water Alliance, Iowa Corn, and the Iowa Nutrient Research Center. So just a bit of housekeeping before we dive into today's virtual field day. You are able to unmute to ask questions following the video, but while it's playing, I do ask that you stay muted so that everyone can hear the video just fine. So we were able to record this video footage earlier this fall when it was a little nicer than it is today. So we hope that you enjoy it. In today's virtual field day, there'll actually be 2 video sections. So following this first video, we'll have some time for questions, and then we'll play a second part, and we'll follow it up with more questions after that. So thank you all for joining again. Following today's virtual field day, you'll get a brief email evaluation asking you to give us some feedback on how today went. It's a pleasure to introduce our presenters in the video, and as well for here question and answers. We have Matt Helmers, Iowa Nutrient Research Center Director, and Chris Hay, the Iowa Soybean Association Senior Research Scientist, Shane Wolf with the Iowa Department of Ag and Land Stewardship as an Environmental Specialist Senior, and Mark Schleisman, who was gracious enough to let us record this virtual field day and join us today for questions. So get those questions ready as we go along and enjoy this video.
I'm Matt Helmers with Iowa State University and Director of the Iowa Nutrient Research Center. I'm here with friend and colleague Chris Hay. Maybe Chris, you can introduce yourself and the organization you represent.
Sure, I'm Chris Hay, Senior Research Scientist with the Iowa Soybean Association.
So Chris, we're out here at a site. Tell me a little bit about kind of what we call this site or this practice that we're looking at today.
So we call this drainage water recycling, which is what it says. So what we've got here is a storage reservoir that's capturing drainage water from a drainage district upstream, and so captures it and stores it before it gets to the Raccoon River. And so with the storage, then we can pump out of this storage up to the center pivot that they use to irrigate this field with. And so really what it's designed for then is to capture water when we've got enough to use in times where we don't. And so that's the idea.
So if I'm not mistaken, this one captures both surface and subsurface flow from about 2,000 acres. And I think it came online about the 4th of July in 2021, if I'm not mistaken, when they kind of had things built and ready to be used.
Yep.
And even in, we're in western Iowa, or I guess west central Iowa. Even in these last 2 years, they've had enough water to be able to provide supplemental irrigation for the crop field.
Yeah, this one has turned out to be a really nice site for that both from the drainage district discharge as well as some of the surface runoff, it's kept it pretty well full. The other thing is he's got kind of a unique situation where he's got sandy soils on top of that clay layer. And so with the slopes on both sides of this, as that water infiltrates down to the sand, it hits that clay layer and then moves laterally, and then that helps refill the storage as well.
So this drainage water recycling concept, this is kind of a, in a sense, a unique site where it could be situated on the downstream side of that drainage ditch. Was this land used for crop production prior to putting in the pond that we see behind us, or storage facility we see behind us?
the storage itself was in the waterway, and so that was, again, a nice convenient location where we could just create this embankment. We didn't have to take land out of production. The land that's irrigated, that has been in crop production before, but again, with kind of that sandy soil in the topsoil, there were lots of times where he would run out of water during the summer, and so having this supplemental irrigation then helps him get through those dry periods in the summer.
Yeah. If I'm not mistaken, from our monitoring that we've done here, estimated rainfall is about 9 inches from kind of mid to late April through late September. So only 9 inches, not a lot for, especially on a sandy soil. Mm-hmm. But I think then they applied somewhere around 7 inches of water as supplemental irrigation. So by the time we have the virtual field day, we'll have the yield data to be able to summarize and share with folks as well.
Yeah, yeah, and one of the things that Mark does is grows popcorn, and so it's a little higher value crop, and so when you're doing that's a good incentive for having that irrigation. But when you're growing that higher value crop, you want that certainty of having water to get that through to full yield.
Yeah. So some of the projections I've seen are maybe wetter springs and drier summers. Might this practice maybe even have greater benefit if that kind of comes to fruition, if we see a little more of those types of years moving forward?
Yeah, absolutely. Climate resiliency is one of the big ideas behind this practice, and certainly we're already seeing that trend, and all indications are that trend's going to continue. The more water when we don't need it in the spring, and then more dry periods, longer dry periods in the summer, and so this practice really sets itself up nicely for that we can capture the water when we got it but don't need it, and then use it when we do need it later on.
Okay. And so this one we see behind us, there's a sump here and a pump that would pump to the center pivot. So this landowner, Mark, is familiar with center pivots, but that might be something that moving forward for those interested landowners, there'd be a little bit more operations and maintenance associated with this, because and maybe something new to learn about irrigation and pumping for irrigation water.
Yeah, certainly there's some irrigation in Iowa, certainly in the river valleys, not as much outside those river valleys. So yeah, irrigation is going to be new to a lot of people. Obviously, we're using the center pivot here that Mark has. Doesn't necessarily have to be a center pivot either, so there may be some other options for irrigation depending on the individual site. And so particularly flat sites, you may be able to just reuse the drainage system itself, and so put water back in through that drainage system, raise up the water table below the crop root zone, and the crops can access that water that way. So for some folks that may be an easier way to do that, but other sites are going to have to use something like a center pivot, or there's been some interest from some folks as well in subsurface drip in some situations. So really you can use whatever irrigation system makes the most sense.
So something for all of us to research into the future, what might be the economics of the different systems maybe for different crops in Iowa.
Yeah. So where sub-irrigation with the drainage system makes sense, that's probably going to be the most economical. If it doesn't work for that, if you've got a field where you can do a full circle with a pivot's often going to make the most sense there. Smaller, odd-shaped fields or higher value crops, then subsurface strip may make more sense in those locations.
Okay. So Chris, this is one of the sites. Are there other ways this could be done, or is this type of practice going to work at kind of all fields in Iowa, or what might be different ways that we could think about drainage water recycling?
Well, I mean, we are engineers, and so we can engineer something to work. Now, the next question then is how much it's going to cost. And so, certainly some sites are going to make more sense than others, and some are going to be cheaper than others. This is a site where, because we were able to create the embankment, it's a little cheaper than if we had to do a lot of excavation. Where we got to do a lot of excavation, storage is expensive, and so those sites are going to tend to be more expensive. Again, depending on the irrigation system, that's going to be a big factor in how we design the site, and then also how expensive it's going to be. And so, we could probably engineer something to work at most sites, but some are going to lend themselves to being more suitable than others.
And I'd say this is, you authored a Frontiers in Agriculture paper to kind of illustrate that there's a lot of need in this space, and I would say that might be one of those areas that's need is that there is a need to understand the cost effectiveness of this practice and understand, where it might work well and where it might not be quite as cost effective.
Yeah, absolutely. And I think some of the early research that some of the grad students here at Iowa State have done, looking at some of the economics, is it looks like maybe with kind of current corn prices that we're getting close to breaking even on the irrigation system, not including the storage. As we move forward in time, then a typical corn soybean rotation, then it's going to start to pay off that irrigation system because of those the concern about drought and longer drought periods moving forward in the summers. And so it looks like even on a traditional corn soybean rotation, we can get to where the irrigation system will pay for itself. Then the big question becomes, how do we pay for the storage? And so that's where I think the research on the water quality side becomes really important, because not only are we getting the crop production benefit from that supplemental irrigation, but by capturing and storing that water and recycling it, we're also preventing the nutrients that are in that water from going downstream and causing downstream water quality concern.
All right, and we will dive into more of that water quality with the second video. So again, if you have any questions, you're welcome to submit those in the chat, or you're welcome to unmute as well. I will put into the chat that link to the Frontiers paper that was mentioned in the video, as well as a couple additional resources from Transforming Drainage that have been related to this particular practice. So one question that's come in is related to how you mentioned that there's a few of these. How many sites do you have established with drainage water recycling here in Iowa?
So I can answer one part. So we are evaluating 3 sites as part of work that we're doing. Chris and I, and graduate student Tyler and Eric. One near Story City, one south of Fort Dodge, and then the one we talked about here. I think there's another site or 2 near the Iowa City area, but we're not, to date, we've not partnered with that landowner. I should say the one near Story City is going on a few years of using supplemental irrigation. The one near Fort Dodge was set up. I see one of the individuals on. Was set up this year and constructed, but then there wasn't any water to put in the pond. So, but we will hope we get drainage, which I would expect in the spring of 2023, that we can use for supplemental irrigation at that site.
And they chimed in that yes, they're hoping to use it in the 2023 crop year. So a question, and maybe this is related both to the design, and then maybe Shane, if there's any technical related to cost share related to this. How big is the pond/storage basin itself, and compared to the watershed acreage that's being drained into it? So toss this first to Chris and then over to Shane if there's additional cost share related numbers.
Well, maybe I'll start in general that from some of the research we've done so far, it looks like kind of 4 to 6 inches of storage for the area that you're planning to irrigate is kind of the sweet spot. And so, that's kind of what we've been shooting for. I think we're a little bit smaller than that on Mark's site, but because we realize that that one's going to be more likely to continue to fill up throughout the year. So other sites we've tried to get somewhere to that 4 to 6 inches of storage. And so, how big that area then needs to be depends on the depth, and so the deeper you can make that storage, the less surface area you need. If the storage if it's shallower, then you're going to have to require more surface area.
And then Shane, do you have any design specs that?
Sure, yeah. So for the drainage area for this particular project, we have around 1,400 acres coming into it with a pool size of right around 3.7 acres. And surrounding that is basically in total 10.4 acres. So we have a buffer that surrounds the reservoir. to basically accommodate and take into if we have any storm bounce. And the final design called out an available irrigation of 588,000 cubic feet of storage. Now we did have a little bit of change during the construction process because where the original sheet pile structure weir was supposed to be put in, we ran into sand issues, so that structure was moved north. But I think Mark worked with the engineer and the contractor, and basically was able to kind of on the fly get back that storage that was lost by having to move the berm up a little bit further north.
So speaking of Mark, if you're just a follow-up question on that, how was the experience in getting this constructed in terms of someone approaching you for it and making it happen?
It was from beginning to end, it was almost a 2-year process, but construction actually went really well. We were fortunate in the sense that it was super dry, because the site can be, because we're on top of that clay pan, there's a lot of surface water that comes in, or subsurface water that comes into that area. But because it was dry, that was a lot easier to work with. So construction went pretty well, other than when we hit that sand lands, had to move the dam, if you want to call that, a little bit one direction and do a little more excavating on the one side. So we did have to maintain close to the original pool level and water storage. But I would say it went well.
Excellent. So another question that's come in. So maybe this one's for Chris. For creating storage with embankments, how are farmers navigating potential issues with WOTUS and the Army Corps of Engineers?
That is a good question, and Shane may be able to chime in on this one as well, because that became a little bit of an issue with Mark's site. So yeah, if it is in areas that are going to be subject to Corps of Engineers and 404 permits, then you're going to have to come up with some way to compensate for that construction within the waterway. And so yeah, permitting is always going to be an issue when you're working in floodplains and those types of areas.
Yep, absolutely. Just to add on to Chris's, yep, we had to submit a full 404 joint application, kind of working with Mark on his behalf. Was able to get the project permitted under one of our regional permit 39, working with the Corps, and then our engineers worked with our floodplain staff. But yeah, it's definitely one of those things. Mark had alluded to the couple years that can take, and that's just one of those kind of things that does take time to work through. So definitely something we have to make sure we follow all the rules and go through all that process, but it does slow things down a little bit.
Shane, can you remind me for the other site that was put in under the IDOLS EPA grant, where it's pumped from the drainage main into the pond, what was the permitting or permission process for that one? So
yeah, so that project was all non-jurisdictional from a permitting standpoint. The one thing that was, if I remember correctly, we did have to get drainage district approval, I believe. So a little different situation there. But yeah, that was a much more streamlined permitting process.
Yeah, and their participating landowner who has one as well did not remember any issues. And then the Board of Supervisors was actually surprised that they were asking to take water out. So
yeah.
There is one other permit you do need to get, and I'm not sure if that was done on the other sites, but if you use over so many, I can't remember the threshold gallons of water, you're supposed to get an irrigation permit regardless of the source. And that's pretty easily done through the DNR.
had you had experience with irrigation prior to this project, Mark?
Yes, so I did that part of the application and it was seamless. There's just got to be a public notice and approval in case there's any objections to use water in that way. We have to do it when we use it out of a well, or if we use it out of a gravel pit, or whatever your water source.
Yeah, for most of Iowa's rain-fed agriculture, that would be a new pathway to navigate. But it was mentioned in the video, Chris, that there was a buffer around that. Was that an established buffer, or did you have to seed that? And if so, what was it seeded to?
Yeah, that was area that was already, kind of, it was already in perennial vegetation. So really didn't have to, had to do some reseeding because of the construction, but it wasn't a new seeding, I guess, maybe the way to put it.
Yeah. Prior to this, it was a pastured area, so it had grass. The construction area was then reseeded with, I believe it's just brome, growing, established quite well, and to hold the sidewalls and everything in place.
And Shane, for any other new constructed sites, is there recommendations or choices on what gets seeded around these storage areas?
Yeah, I mean, we try to incorporate natives when possible. For like our CREP and Water Quality Initiative wetland projects, we typically work with the local NRCS field office, to basically get approval on a seed mix that they recommend. Critical area seeding, of course, you'd like to see like a brome, so you get something more fast established. But in that buffer area, I think if we can use like something like a CP25 mix or something like that, it works well.
All right, so I had one more question as I was preparing for this. Because you're pumping out of a storage facility, are there any concerns about pulling in any sediment into the system as you're pulling from the storage area?
I can address that a little bit. I mean, there was, the way this is done, it's called a wet well. So a casing goes down adjacent to the pond, pipe goes over to the pond, and then the inlet's about, excuse me, about 2 feet off of the bottom. Now, over time, that may get some sediment in, who knows? But then right before it goes into the pivot, there's a screen, and that should screen out anything that's going to cause problems with the pivot. And it's a self-cleaning screen that if I see pressure rise on the pivot or drop on the pivot that it's not getting enough water supply, there's a valve you can open and the pumped water cleans the screen off, and then you go again. But in the 2 years we've used it, there's been nothing on the screen, literally nothing. I was worried about maybe even moss or algae in addition to sediment, but there's been nothing there. There's been some moss or algae in surface waters, but not at the depth we're pumping from. So there are things you can put in line that if you're worried about sediment, you can do that. One other thing we did for sediment here is just below where the county tile dumps and before it gets into the pool area of the pond, we cleaned out an area, I suppose it's probably 50 or 60 feet long by 20 feet wide, and dug kind of a sediment basin right there, so that if sediment comes into it, it'll hopefully get caught. Most of it will get caught there before it goes into the pond and wetland area. And so we can observe that and periodically clean it out to keep sediment out of the pond.
Yeah, so there's a question here of what is the depth of that storage pond?
Shane probably has the detail. I know there's a couple very deep holes where they dug some of the clay out to build the dam and coat some of the sides where the sand was. And those are probably 20 feet deep, but they're not very big areas. The deepest area of the design was about 5 or 6 feet, and a lot of areas that are 3 feet, 2 to 3 feet.
Shane's nodding with agreement here.
Yeah, you covered it better than I could, Mark.
And so, Chris, in the design process for these, does that potential overland flow of sedimentation taken into account in terms of like lifespan and things like that?
Yeah, it would need to be. And so part of that's going to depend on the water source. So if it's purely subsurface flow, we're going to be a little less concerned about sediment. If we are trying to capture surface runoff, then kind of what Mark mentioned, that ideally we'd want to have kind of a sediment forebay where we could let that sediment laden water come in, let the sediment hopefully settle out, and let the water go into the deeper storage after removing some of that sediment. So that's going to help with some of that sediment issue. And then again, kind of in the design of the intake to the irrigation system, making sure we design that in a way that we're going to try and minimize any sediment issues as well.
All right, well, keep those questions coming in. I'm going to play part 2, where we dive into a little bit more of the water quality and see what additional benefits these systems can provide.
So that's kind of a good segue to talk about what's being done here from a water quality standpoint. And so at this site, we're monitoring the quantity of water coming into the storage pond. We are taking daily water samples of that for nitrogen and phosphorus, and then we're taking samples from the storage area itself for nitrogen and phosphorus, and then monitoring the quantity of the water leaving the pond and collecting nitrogen and phosphorus samples for that. We started to do that in 2022. The nitrate concentration coming in is fairly consistent, about 15 milligrams per liter. And then leaving the pond area, it's about 9. So we're seeing, 30 to 40% reduction in nitrate concentration as that water moves through the pond. And then, so, even if all the water that came in that was leaving, we'd see 30 to 40% load reduction. But in this case, we're also taking a portion of that water and sending it out for the center pivot. So we're getting even greater than that nitrate load reduction with this practice at this specific site. So I think it kind of illustrates the potential for this as a water quality practice in addition to maybe crop performance practice.
Right, and so it's in line with some of our other edge of field practices, but unlike saturated buffers or bioreactors or even wetlands where there's really no economic benefit back to the farmer, this one does have that economic benefit then of that supplemental irrigation and the crop production increase from that. So again, that's a way to incentivize this. It might be a little easier sell than some other edge of field practices, particularly for some farmers. And so we've got that additional crop benefit as well.
Maybe one of the things is also to, some of these sites, if we get more of them, understand, are there any waterfowl or wildlife habitat benefits around them? They may not have as much buffer area or maybe have, the aesthetic value of the wetland, but there may be some, at least small value of that for wildlife habitat or waterfowl habitat.
Yeah, absolutely. And that's something we can design too as well. And so, depending on how we design and manage the system, we can get some complementary benefits beyond just water quality and crop production. So, if we put some shallow water area in there as well as the deep water that we need to pump out of, then we could create some wetland type habitat. Obviously, we've got the deeper water habitat that does provide some wildlife benefits as well. And then, what we choose to do with the buffer can provide some wildlife benefits as well. And there may be some other opportunities for benefits too, that if we do this at a large enough scale, we've now created storage on the landscape, and so depending on how we manage that, we may be able to have some benefits for downstream flow, flood peak reduction as well. So I think there's opportunities depending on how we design and manage these, and that's another open area for research to see how we maximize the benefits of these systems.
Okay, at this site, as I mentioned, there's a drainage ditch there's a drainage main that discharges as well as surface runoff. That comes underneath the road up there, and then there are 3 large culverts that we're monitoring on after that surface and subsurface flow has combined. That flows into the on-farm storage, the pond that we see here. And then there's a large sheet pile weir as the exit. And so there's a normal pool elevation that's controlled by that sheet pile weir. And then that large weir, allows for a lot of water to pass through if they get a very big runoff event here with minimal bounce of the system. The intake for the sump is down toward the bottom of the storage pond, so they can access as much storage volume as they can. So with this more managed system, the irrigation system, would it allow the farmers to think about maybe more fine-tuning their management for their crop, or thinking about how they do nutrient management for crop production? Does it open up any opportunities there?
Yeah, so certainly we're recycling nutrients that are in that water back into the field. Now, what's in the water, both the concentration and the amount of water that we put on. It's probably not going to change the overall amount that they're going to apply because it's going to be fairly insignificant relative to the crop needs. But what it does open up is some additional management capability that they didn't have before, because now we've got that irrigation system. And so it opens up the idea of fertigation, where we could be applying nutrients through that irrigation system throughout the year. And so where we may be limited to a fairly narrow side dress window for traditional side dress, now we can use that irrigation system to put on nutrients, when all through the crop season. So it really does open up some management capability that we didn't have before to really fine tune that nutrient management and really only apply what's needed when it's needed.
And have the water there to move that to the plant root zone. Because I know we have a case in Northwest Iowa in 2017 where we side dressed in early July, but then only got an inch of rain in the month after that. And so that nitrogen that we applied never got moved to the plant root zone. So with this, we know we have the water to move that nitrogen into the plant root zone.
And controlling that water gives you some other management capabilities as well. So, if it turns out to be a dry spring, you've got some water if you need to help germinate a crop. And then likewise in the fall, if you're trying to establish cover crop and it's dry, we know the challenges of trying to establish cover crops when it's too dry. And this year was one year that illustrated that in a lot of locations. And so having some water to get that cover crop germinated and established can help with that aspect as well.
And so one of the other things is, perhaps if we had some of these systems, it might be easier to implement some of the intercropping, relay cropping type systems where we maybe have a small grain followed by soybeans, that maybe there's some concern about deficit water stress for that soybean crop, but now we have water to really help that crop get through the growing season.
Yeah, absolutely. And again, that's another way to kind of intensify that system and create some more value that supplemental irrigation can help provide. I think of another aspect would be seed corn production or things like that as well, seed production, where you want that guarantee that you're going to get a good yield or good be able to fulfill those contracts. And so having that water gives you that ability to be a little less worry about the risk of losing some of that crop.
Chris, we have many edge of field practices. I think there's a lot of potential with this practice. Where do you see as some of the research needs, and maybe where do you see we are as far as seeing more of this out on the landscape?
Yeah, certainly, a lot of the research is still really around the costs and benefits of these systems, and so I think we've at least got a pretty good handle that yes, we are going to see a yield benefit from supplemental irrigation. Now the question is that enough of a yield benefit to pay for the system? And I think right now it's pretty clear that probably good chance we can pay for the irrigation system. It's probably not likely that we're going to be able to pay for the storage unless it's a really high value system. So then we really need to get a handle on what are the public benefits, the water quality benefits, and so what's the value of those, and then how can we pay for that to get those benefits. And so certainly a lot of questions around the economics. Then again, some of the management, how do we best manage these systems to get the maximum benefits both for crop production and water quality, and then any other benefits that we design and manage the system for. So those are probably the main research benefits. We do have, we worked with NRCS to get a conservation practice standard at the national level. So, if Iowa chooses to adopt that standard, then it becomes EQIP eligible. So that's one way to start paying for some of these systems. Iowa Department of Ag and Land Stewardship, IDALS, has also shown interest in this idea in these systems as well. And so right now, there's some potential to get some help with the storage side of the equation for some cost share assistance that way. So, that can help get some of these early sites up and going. And then as we learn more from more sites, then hopefully that allows us to continue to continuously improve and get more sites going so that we can start to scale this practice up.
Yeah, I think that's a good way to think about it, is that this may not be something that there's that we want to we're probably not going to be able to do all the practices with state and federal dollars, but especially in the early stages of this, trying to, get some help for the farmers to put them in to understand it. Then hopefully, it might be able to scale up after that if we can see the benefits to the crop production, and maybe there is some, ecosystem service benefits and future payments for ecosystem services that help with that.
Yeah, I think those market-based approaches may be the wave of the future as a way to really incentivize these, and with the storage and the whole system, we've got a lot of ways that we can actually measure and quantify those benefits and have real verifiable outcomes to be able to market that way.
Yeah, sometimes some of these engineered solutions are a little bit easier to quantify the benefits of, because we have a pretty defined inflow point and outflow point that we could measure and quantify what's coming in and what's going out, and the rate at which it's coming in and out.
Yep, absolutely.
All right. Well, we've had some questions come in, so I'm going to start with those. And again, if you got them, send them in the chat. If one were to irrigate with, say, a 5 acre inches of water for a corn crop and nitrate levels in the irrigation water were 5 parts per million, how many pounds of nitrogen could one credit to the corn crop? Get your pencil and paper out.
So we have 5 inches of water, and it's 5 parts per million. So probably only about 10 pounds.
All right. That was impressive, Matt.
That I didn't put pen to paper, but I'll just say at Gilmore City, we lose about 10 inches annual long-term average on drainage. Our nitrate concentration's about 14. That ends up being about 30 to 35 pounds of nitrogen. So somewhere about a third of that.
So not maybe as much
It'd
to take
be less than that. It'd probably be closer, 5 to 10.
Yeah.
I think, Chris,
Yep.
you noted that there wasn't much of a nitrogen credit taken, and Mark can probably confirm that as well.
We certainly want to account for it, but you're probably not going to make large changes in your nutrient management plan because of that.
But in this case, knowing what we're pumping on and how many inches on a sandy field I would be using, I will credit my nitrogen total need by about 15 to 20 pounds.
Okay.
Because on a sandy soil here, I know you measured 7 inches, but we had irrigated some prior to that measurement starting. I think we actually applied over 10 inches of water to this field. But I would credit that. It's no different than a half a side dress application.
Without having to run yourself, be out in the tractor yourself, running that equipment through the field.
Yep.
So a question here, could existing pond storage systems be retrofitted to add the irrigation properties?
Yes, I get the question's going to be, is there enough storage to make that worthwhile? And so that would be a question on, how much storage is actually in that pond and whether it's worth the effort to go ahead and put that in. But yeah, as long as it's, approximate to where you want to irrigate and there's enough storage there, that's something that could be done.
Mark, a question for you. Do you do any fertigation on your other systems?
Yes, we do. We try to put, I would prefer to fertigate than run a side dress applicator across the field just because of the trip and, driving over the soil and crop damage, turning on the end rows. So we will fertigate some 32% nitrogen prior to tassel on our field corn. Some on the popcorn, but not so much on this popcorn seed. And this system has the check valve. You have to have a check valve to do that. And we have that in place for this. I didn't put any on this year, but I plan to in the future.
So it's not that, depending on how it's designed, if it's being fed by tile drainage, that could work anywhere in Iowa, but are there some slope limitations when it comes to actually doing any of the irrigation?
You know, there's certainly slope limitations if you're looking to sub-irrigate where you're actually putting the water back through the tiles. That's going to be pretty limited to flatter sites. Center pivots can run on some pretty good slopes. Certainly there are some extremes that you would probably limit that, but for the most part, center pivots can run on some pretty good slopes. If it's a field that is otherwise set up for subsurface drip, that can have some slope limitations too. But with pressure regulators and things like that, there's some ways that we can overcome some of those as well. Hard to think of too many places in Iowa where it's completely out of the question.
Yeah, and with LiDAR and pivot design, you can adjust the length of your spans and keep your tires on top of the hills instead of running down just in the valleys and not having enough clearance then with your spans. So you can put taller tires on to maintain clearance, and through design of the length of those spans, keep them in the high spots.
Right.
So a pivot can flex a lot over variable terrain.
So someone has a question here. Is there any concern, and so I'll direct this first to Matt, and then if anyone else wants to chime in, but is there any concern of algae growth that could affect the water downstream of this system?
Might be something to look at, but the algae growth we'd see in there is probably similar to what we'd see in a lot of our wetland systems. That might be put in for nutrient removal as well.
And as far as downstream of the overflow, it should only be better because we've removed nutrients.
Right.
Better mean less.
Yes. And so maybe, I guess, if there's a clarification from this particular person, if you were considering like cyanobacteria algae, or if it was true algae.
And that has been a question that's come up is, do we potentially create a blue-green algae or cyanobacteria concern? It's nothing that's been documented so far. So, I think that's another one that we'll have to kind of wait and see, but don't anticipate that that's going to be an issue.
And so it was referenced in the video there a little bit about some cost share opportunities. So Shane, is there anything you want to add or elaborate on from the IDOL's point of view or what you've heard on the EQIP front as well?
Sure. Yeah, maybe I'll just mention quickly kind of how the couple projects that we've worked with, how those were done, and then kind of the funding that's available right now. So this project we're talking about today, and then another one that was referred to earlier with a little bit different concept where we're pumping from a drainage district tile main. We're both supported by state funding, but then also with EPA Gulf of Mexico funding. And then there was actually cost share that was put in by the landowners for the irrigation part of the project. So that was a research grant that we've managed that's going to be closing out here now. And as Chris kind of alluded to in the video there, we are still looking for opportunities to help cost share on like the reservoir itself. And so we have a couple projects now that we're in development that are in development and design where we're going to help kind of support those reservoir costs, and then the landowners working to basically facilitate the irrigation component of the project. So I personally don't have any updates regarding the EQIP standard. I don't know, Chris or Matt, if you've heard anything from that end. I think there may be a standard that's been development. But.
Yeah, so we worked with NRCS to get the standard at the national level, and so it has been approved at the national level. Then each state, it's up to them to approve it at the state level. So I know Illinois has approved it at this point. Iowa has not yet. So, I know there's some efforts from the state tech committee to bring that issue forward and see if we can't get that adopted here at the state level in Iowa, which would then make it eligible here in Iowa.
One thing I'd like to point out is just a bank, to promote somehow getting this on the cost share list. A project like this is, if there's 1,700 plus acres in the watershed above it, it would take 15 to 20 bioreactors or saturated buffers to do what this project has done, essentially. It's a 24-inch county main that discharges into it, which is too big for a saturated buffer or a bioreactor. But this project basically does what 15 or 20 of those projects would have done. And in the end, the thing I like about it is it has an economic benefit in that we're capturing that water, we're capturing those nutrients, using them on a field, seeing an economic benefit to that growing crop, where a saturated buffer or a bioreactor is doing its job in reducing nitrate load, but there's no dollar economic benefit to putting in the structure other than doing what's right and reducing the nutrient load.
Yeah, and I think that's, it's just making that case right now. And I think, if we can make that case, then I think, it may just be an awareness issue right now that Iowa understanding what that is and that it's available and actually implementing it. But I think there's a strong case to be made that for this practice. And so hopefully, we can get that done.
And out of curiosity here, has there been any research or plans to do some sort of wildlife analysis of habitat and impacts in the watershed?
Oh,
It's
no
on the dream
specific,
list.
no specific plans, but wasn't that called out in the Frontiers paper, Chris, that that's a need?
Yeah. And
Yeah.
I will say that there were some similar sites in Ohio a while back, and they did do a little bit of wildlife analysis and found, some significant impacts, particularly on amphibian habitat. So there were some definite positive benefits from that. But yeah, there haven't been any specific plans in Iowa. Certainly, if someone's interested, we can see how we might work that in, and if someone's willing to do that and help pay for it.
Bring the dollars, right?
That's right. Always helps.
All right, well, keep those questions coming in. I am going to share my screen one more time, because if you joined us today for a CCA credit, please send me an email. My email's there on the screen. I'll also put it in the chat. By 5 p.m. today with your name, and if you watched under a different name than your CCA numbers associated, please provide that as well as that CCA number, and I will get that submitted on your behalf to give you the credit for attending today. And if you are interested in an edge of field practice, maybe one of these or those others listed on the screen here, you can also email me at that same email address, and I will help connect you with folks at the Iowa Department of Ag and Land Stewardship to see if your site could be suitable. And don't forget that if you happen to have cover crops or you work with someone who has cover crops, that the cover crop insurance program that Iowa Department of Ag and Land Stewardship has partnered with the Risk Management Agency to do is open. So application deadlines, I believe, are January 13th. So there's time to get that in. And lastly, before you wrap up the 2022 field day season, I hope you can join us next Thursday, same time, same place, where we're going to talk about establishing saturated riparian forest buffers. So tune in to learn about those as they explore how trees and saturated buffers can work together cohesively. So any final thoughts, questions, comments that you'd like to leave the group with?
I will add one thing that you'd mentioned that the other landowner that's on that has one of these systems that they were surprised. Their board of supervisors was surprised that they wanted to take water out of the system. But I think it's worth mentioning that that's another benefit of the system is it can help open up some capacity in these drainage systems. And in fact, I was a little surprised to learn that the site that we're working with in Story City, that was their original incentive for putting in their system was to open up some additional capacity in their drainage system. So, I assumed it was the irrigation benefit that they were after, but that was actually their original incentive. So, I think that's another potential benefit on some of these drainage systems that are maybe a little overtasked, is to be able to open up some added capacity with that storage as well.
Excellent. So again, feel free to check out that Frontiers paper. And if you have questions after the fact, feel free to reach out and I'll get you connected with these folks to further address those. So thank you again for tuning in today and have a great holiday season.